Alright, we're going to be talking about balanced and unbalanced forces today. You should have picked up a Cornell note sheet that looks like this, and make sure that you follow along and fill in all blanks and listen for any cues that I offer you. Here we go. The first question on our notes asks us, what is a force? Well, as we can see looking here on our notes, that a force is going to be a push or a pull that causes an object to move, stop, or change directions. So look at the picture on your Cornell notes. That picture shows us we have a push or a pull here. Okay, so a push would be something pushing towards it like a box. Oops. And then a pull would be somebody pulling in a direction. This is the graphic that you see. Notice how he is pushing here, and then this object is pulling. That's going to be very, very important. So one thing I'm going to encourage you all to do is to circle the tips of your arrows and write down the direction. So this person is pushing which direction. So if this was an object that they were actually pushing, where would it go? This one would go to the right. Okay, this person is pulling. Okay, so think about the direction the object would go that he's pulling. It would go to the left. One thing we need to remember in your notes, in the left column it says remember that forces come in pairs. That's your next blank there. Forces come in pairs, and then they have two things. They have a magnitude. That's basically the amount of force that they have, and they also have a direction, left, right, up, down, all sorts of things. So let's look at a couple examples. Alright, here's a good example here. I have this arrow and this one. These are both pushes. Okay, but let's figure out which direction they're going. The one here on the left is pushing toward the right. That's the direction. And the one on the left here is pushing towards, the one on the right is pushing towards the left. So think about it. If somebody's pushing 4 newtons of force to the right and another person is pushing 4 newtons to the left, what would happen? Well, that leads us to our next topic. This is a balanced force. Okay, this means that it will not change its motion. Here's another example. This time we have pulling forces, kind of like in tug of war, and this arrow here is pulling to the right, but this one over here is pulling to the left. But look at your forces. You have 1,000 newtons pulling to the right, and you have 1,000 newtons pulling to the left. So is it going to go anywhere? Probably not. They're going to have a net force of 0 newtons, and I'm going to go over this again here in a moment. Alright, so next we want to talk about a balanced force. Balanced forces do not cause a change in motion. So your next blank is do not cause change in motion, and they are going to be equal in size and opposites in direction, which is just like the examples you just saw. So going back to our pictures here in our notes here, okay, you have 4 newtons pushing to the right, you have 4 newtons pushing to the left. So like I said earlier, when you subtract it should be 0 newtons. Okay, then look at this picture here. Sometimes you're going to see graphics that don't actually give you the amount of magnitude, so you have to look at the sizing of the arrows themselves. These arrows are equal in size and length, so this is also going to be balanced as 0 newtons because the forces are equal. The donkey or horse or whatever that is not going to go anywhere, or its motion is not going to change. Every force on him is balanced. Okay, now we want to talk about an unbalanced force. An unbalanced force always causes a change in motion. Always causes a change in motion. And there's a couple things that we need to remember. The next blank on your note says calculating. We're going to calculate net force. Net, N-E-T. Okay, this is real simple math. You're either adding or you're subtracting. So you're going to do one of two things. We are going to want to add when our forces are going the same direction, and then you're going to subtract when they are going in different directions. So let's look at this example here. You have 300 newtons going to your right, and you have 300 newtons going to your left. Okay, so this is right, and this one's going left. What do I need to do? I need to subtract them. 300 minus 300 is going to be a net force of 0 newtons. Really simple. Okay, now let's look at the bottom tug of war here. This one's going 300 newtons to the right. This one's going 400 newtons to the left. What am I going to do? Are they the same direction or are they opposite? They're opposite. I'm going to subtract. 400 minus 300 is 100. Another example here. I have, ignore these. This is going to throw you off. Sometimes they're going to do that. But I look at where my arrow's going. Okay. This one is pushing to the left. This one is pushing to the right. Okay. I need to look. They're going opposite directions. Okay. Now, are my forces equal? I have 35 newtons and 40 newtons. They're not, so I'm going to subtract. 40 minus 35 is going to give me 5 newtons. But which direction? So if I'm doing 5 newtons, who has the greater force? That's this girl right here. And remember, hers is going to the right. So it's going to be 5 newtons to the right. Okay, let's get in one more example. Let's say I have this box here, and I got one person pushing 3 newtons this way, and I have another person pushing 6 newtons as well. Okay, so both of these are going to the right. Okay, so my forces are both going the same direction, so I need to add these together, just like the note said. So 6 plus 3 is going to be a net force of 9 newtons to the right. So the final thing we need to do is let's go ahead and calculate the net forces on our notes here. So this picture here and this one here, you have to ask yourselves, are they moving in opposite or the same? So these two are going to be opposites. So I have 50 newtons moving to the right, and I have 40 newtons moving to the left. So my net force, I subtract 50 minus 40 is going to be 10 newtons. And which direction is it going to go? Well, 50 newtons is greater, and it's moving to the right, so it's going to be 50 newtons to the right. Make sure you write that down in your notes. And then I have this picture here. I look at both of them. They're both moving 12 newtons, but are they going the same direction? No. One is pushing to the left, and the other one is pushing to the right. So 12 minus 12 is going to be 0 newtons for this picture here. And then my last picture, kind of a little awkward, but they're going opposite directions. I have 20 newtons that's moving up, we'll say, and then I have 3.7 newtons moving down. Okay, so 20 newtons up and 3.7 down. Opposite direction, subtract 20.0 minus 3.7. Okay, let's do a little math. 1, I know that's going to be 9, 10, it's going to be 3, 6, 16.3 newtons. Which direction? Up, because of the greater force being up. So those are your notes, and make sure you read the board, or no, read the board.